Hi there and welcome again to the channel. It's good to have you here. In today's video, we are examining question number 4 from paper 2 of 2023. It's not written fully on the board because of lack of space, but I did summarize the question, picking up the main points. It says here, this is the equation of a curve, x squared, I hope my squared is visible, x squared y plus 2y cubed is equal to 48. Find the equation of the normal to the curve at point P being the point 4, 2 there. Now let us imagine a curve, the curve to be, roughly like this. There's our curve there, okay? And let us imagine also that this is our point P with coordinates 4, 2. Let's draw a tangent to this curve passing through this point. The tangent, of course, is a line that just touches the curve at the point P. My line is not very straight, is it? Okay, let's label this our tangent. At the same point, through the same point rather, there is a line at right angles to this tangent. Let's draw it in green. So there is our green light is rather faint. Okay, it's rather faint. Let me get some better green here. Okay, so there is our green, a little slightly better, isn't it? All right, so there is our green line. That green line, let's call it L. It is the normal to the curve at this point. And we know that it must be at right angles to the tangent. So these two lines, the normal to the curve at P is at right angles or perpendicular to the tangent at the same point. So those are our two lines. Now, why are we going through finding the tangent when the question says we must find the normal? All right, this is what we need to do. First of all, we want to find the gradient of the tangent. And from the gradient of the tangent, we will be able to find the gradient of the normal. But what is the gradient of the tangent? It is given by the gradient function of the value of the gradient function of this at the point P. So let's differentiate this with respect to x. Obviously, this is implicit differentiation because our equation is not given explicitly in terms of x and y. In other words, y is not explicitly expressed in terms of x. It's not a direct relationship, it's implied. And so therefore we have to use implicit differentiation. And it goes like this. Of course, we can see that here we have a product. And whenever we have a product, what does that remind us of? It reminds us of the product rule. So we must first of all differentiate this x squared, leaving y untouched. Then we differentiate this y, leaving the x untouched, which is something like this. Differentiate with respect to x, we have 2x y, because y remains untouched. Then we come again, we now want to differentiate this y and leave the x untouched. So we have our x squared there, but the y is now being differentiated and it becomes dy dx. We are done with this term here. Let's come over here. Plus implicit differentiation is 3 times 2, which is 6. Then the y, the power of y, comes down to 2. And this is equal to the derivative of 48, which is a constant, is just 0. Now, let's collect our, sorry. We left a dy here. I beg your pardon. It's 2y squared dy dx. 2, which is 6y, y squared dy dx is equal to 0. Let's get that right. we are differentiating this implicitly. It's 3 times 2, which is 6. And differentiating this with respect to x, it gives us y squared dy dx, which is 6y dy dx. So now let's collect our dy's and our dx's, dy dx's together. We can factorize this. So we have 2xy, which is this part here, plus, take out the dy dx. Here, how many times? It goes x squared. Here, how many times? It goes 6y squared is equal to 0. Let's take our 2xy to that side. Then we have dy dx brackets x squared plus 6y squared is equal to, this becomes a minus, so we have a minus 2xy. Okay, so now let's divide every side by x squared plus 6y squared. That then gives us dy dx. Hope it's, let me raise it a little bit. You might not be able to see it. So dy dx, this one there, it remains along this side. Everything is going that side, so it's dividing. So that gives you minus 2xy divided by x squared plus 6y squared. Okay, so now this is our dy dx. Okay, slowly go through what we have done. We have an expression here which is an implicit function of y with respect to x. So when we differentiate this term by term implicitly. We have a product here, so we have 2xy differentiating x squared first. Then we come here, we differentiate y, we get our left, we're left with the x squared, so it's x squared dy dx. Here it's the power multiplied by this 2 gives us a 6. Then differentiating y cubed gives you y squared dy dx. Differentiating 48 gives you 0. So we collect the terms here that are associated with dy dx, and we result with that. Then we isolate our dy dx, we put everything one side, there is our dy dx, implicit differentiation. But now we want to find the value of dy dx because we want the gradient of this line. So we have to evaluate the dy dx at this point. So let me just clear this part of the board to create some space there. Okay. Now that we've got our dy dx, okay, so, right, so dy dx, allow me to write it like this, dy dx evaluated, this line here, at the point 4, 2. Can you see that? This dy dx evaluated at the point 4, 2 is equal to, so we put 4 for x and 2 for y. That gives us 2 multiplied by x is 4 and y is 2. This is minus, of course. And then divided by x is 2, x is 4 squared is 16 plus y is 2, which is 4 when it's squared, multiplied by our 6 gives us a 24. Okay, 6 times 2 times 2, which is 24. Simplifying this, we have minus 8 times 2, which is minus 16, divided by 16 plus 24, which is 40. Of course, we can simplify this, divide through by 8. That gives us minus 2 over 5. This is the gradient of this line here. Minus 2 over 5. Right. Now, what is this got to do with the normal? Well, when two lines are perpendicular to each other, and you know the gradient of one of the lines, the gradient of the other line is always minus the reciprocal of the gradient of the other line. So this is perpendicular to that, and the gradient of this one is minus 2 over 5. So the gradient of this will be minus the reciprocal of this one. So gradient of, again, I'll clear this part here. Okay, I don't need all this surely. So, okay, remember, this is the gradient of our tangent. So the gradient of the normal, we can write grade, I'll write in short, grade of normal is equal to minus bracket 1 over 2 minus 2 over 5. Remember, it's minus the reciprocal of this gradient. So the two negative signs cancel out and the 5 comes up and it becomes 5 over 2. So this now is the gradient of the normal here. What else do we know about this normal? Well, it also passes through the point 42. So we know the point it passes through, we know its gradient, therefore we can find the equation of the normal. So what is it? We know that it is y minus 2 divided by x minus 4. And what is this equal to? It's equal to the gradient, which is 5 over 2. Cross multiplying, we have 2y minus 4. 2 times 2 is equal to, now we are multiplying there, 5x minus 20. Okay, 5 times 4. Collecting terms, everything to one side. Let's put everything to the right. So that gives you 5x. Y comes here, it becomes minus 2y. 4 becomes plus 4, and then minus 20. That becomes minus 16 is equal to 0. This is the equation of the normal. Imagine that the question was 7 marks. I truly believe the examiner was in an extremely good mood. But that's the question there. It involved quite a number of things. Implicit differentiation. It involved the idea of the equation of a normal, the relationship between two lines perpendicular to each other in terms of their gradient, etc., etc. Quite a bunch of concepts there. But that's how examinations are always like. They test you on a lot of things in one question. Till we see you again, bye-bye and have a good time.